Hey everyone, for the last day of this section, focusing on the area between curves, we're just going to run through 4 more problems. And really here I want the emphasis to be on the setup of these problems, so we'll use our calculator to evaluate all of the integrals. Again, I really just want to make sure we focus on the setup and why sometimes we make decisions to integrate with respect to x or with respect to y. So for number 1, I have 2 functions here. Sorry, I'm trying to focus and it's not going so well. Whoop, there we go. All right, so I have 2 functions, and the first thing I notice is that they're solved for x in terms of y. So that makes me think this is going to be a right minus left problem. And if I look, I notice that doing right minus left, I always have the same right boundary and I always have the same left boundary. So it lends itself really nicely to setting up integrating with respect to y. So I know when I'm integrating with respect to y, I'm doing right minus left. Well, my right bound of this region is going to be y squared. And my left bound is going to be y cubed. So my integral is y squared minus y cubed. Of course, I have my dy, and again, we're doing right minus left. And now the other piece is my limits of integration. And so here, remember, we have to be careful. When we're integrating with respect to y, our limits should be y values. So it looks like I'm integrating from 0, and then I'm grabbing my y value here. So I'm integrating from 0 to 1. And again, those have to be y values. So this is a nice and easy one to set up. So now we'll just go to our calculator to evaluate it. So I'm integrating from 0 to 1, and I have x squared minus, and remember this variable does not matter. We just use in terms of x when we're typing in our calculator. And we're going to get 0.083. And again, I'm always going to 3 decimal places because that's typically the standard for the AP test. Okay, so that was a nice straightforward example of when we would do right minus left. So for number 2, let's take a look at what we've got here. I've got 2 curves. I've got y equals 2x squared. So I'm going to do this here. I know that's my y equals 2x squared. And then I've got here y equals x to the 4th minus 2x squared. So I kind of did that in color just to help me visualize what's going on here. And when I look at this one, it looks like if I do top minus bottom, my 2x squared is always going to be the top, and x to the 4th minus 2x squared is always on the bottom. So this one actually lends itself really nice to just integrating with respect to x, since my top and my bottom are always the same. I'm not going to have to split this up at all. So now I'm going to have the integral. Again, I'm doing top minus bottom. So we said our top was 2x squared minus the bottom, which is x to the 4th minus 2x squared. I have my dx. Now I need my limits of integration. Now, since we're in terms of x, our limits of integration are going to be our x values here. So I'm integrating from -2 to 2. And again, we'll just use our calculator to do that integration. So let's see, -2 to 2 of 2x squared minus, oh, can't see that because of the glare here. 2x squared minus, again, I'm going to be careful to use parentheses here because otherwise I'm going to have problems with my signs. dx. And my area is going to be about 8.533. All right, so let's keep going. All right, on number 3, now this is one, if I look, this is one where I'm really not going to be able to get around using separate integrals. To me, it still seems that top minus bottom is the best way to go. Everything's solved for y in terms of x, so I wouldn't have to do any rewriting. And even if I did do right minus left, I'm still going to have all sorts of splitting that I'm going to have to do. So I'm going to treat this as top minus bottom. We're just going to split up our intervals. So the first thing I see here, and maybe it'll help to kind of outline our functions here so we can easily pick up what's top and minus, or top and bottom. So there's my negative x plus 2 is the pink. And in blue, we'll do our 4 minus x squared. All right, so my first interval is going to be the integral. My left bound here is negative 2. Again, I'm doing in terms of x, so I'm going to have x values for my limits. So negative 2 to negative 1 here. My top in this case is the pink, so negative x plus 2 minus the blue, which is 4 minus x squared. So that's for my first region. Now I need to add the integral. Let's see, it looks like I go from negative 1 all the way over to 2. Now my top is 4 minus x squared, and I'm subtracting a negative x plus 2. And then for my last interval, now I'm going from 2 to 3. And let's see, my top is back to negative x plus 2, and I'm subtracting 4 minus x squared dx. So I'm going to use my calculator. I'm going to just enter that in. You can go ahead and simplify these, but usually if I'm using my calculator, I just leave them as is. So let's start here. Negative 2 to negative 1. And hopefully, as long as I'm not typing anything in wrong, we should come out with the right answer. All right, and I'm going to get 8.167 for that total area. All right, one more to go then. All right, so now it's asking us to find the area of the regions enclosed by these graphs. So first of all, my guess is this is going to be a right minus left situation, because it's going to be easiest to solve these for x in terms of y. So I'm going to get x equals y squared, and then x equals, let's see, this would be 3 minus 2y squared. Now, I do need to take a step back, because in order to figure out what's the right and what's the left, I need to get a picture for what these functions look like. So I'm actually going to go ahead and solve for y. So if I have x equals y squared, I know that y is positive or negative square root of x. And then here, let's see, I would get 2y squared equals 3 minus x. Y squared is 3 minus x over 2. And so y equals positive or negative square root of 3 minus x over 2. So I'm going to use my calculator to go ahead and graph these and see what this region looks like. So I'm going to have 4 functions to enter into my calculator. So I'm going to get rid of this. So I have square root of x. I have the opposite of the square root of x. Now let's see, I have the square root of 3 minus x divided by 2. And then I have the opposite of the square root of 3 minus x divided by 2. Okay, so we've seen some regions like this before. And if I go to a standard window, maybe we can get a better idea of what this looks like. So there's my x equals y squared. And then now it's graphing our x equals 3 minus 2y squared. So I'm just going to draw in a rough picture of what this looks like. So I have this region here. And then I have this here. Okay, so that's a rough sketch so I can figure out what's going on. Because now we want to verify. It wouldn't make sense here to go from top to bottom because as you can see as we go through, those boundaries are going to change. But it looks like if we go from right to left, the right boundary is going to stay the same and the left boundary is always going to stay the same. So this we knew was x equals y squared. Right? And to make that stand out, I'll just trace that in purple. So that's going to be our left. And then we've got, I said this was x equals 3 minus 2y squared. And that one we'll make in blue. So that's going to be our right boundary. All right, so we are going to do right minus left. So I'm going to set up my integral. Again, my right function I know is 3 minus 2y squared. And I'm going to subtract my left, which is minus y squared. That's dy. And I'm going to use my calculator now to get those intersection points. Remember, they're going to be the y values of those intersections. Let's see, I'm going to change my window here. Maybe make it a little smaller so I can see things a little better. Let's see if we fit in here. Okay, so now I'm going to calculate my intersection point. So I'm going to come down here. Here we go. So I'm on negative square root of x. Now I need to get down here. That's where I want to be, and I'm going to hit enter. Again, I'm picking up the y value of that intersection, so my lower limit is negative 1. We'll calculate intersection again. Enter. And our upper limit is y is equal to 1. So now we can use our calculators. Whoops, let me get out of here. To calculate that integral. So negative 1 to 1 of 3 minus 2x squared minus x squared dx, and I get an area of 4. So again, there was nothing new for today, but just going through some more of these problems to help us really zero in on how we set these up and why we make the decision to do top minus bottom or right minus left. So we'll have one more day of practice on this before we kind of wrap it up at spring break here, and we'll move on to the next topic when we're back.